Have you ever wondered what's really going on inside the mind of an AI? Today, we're going to pry open that black box and take a look at how these incredible systems actually, well, how they think. Let's dive in. So, it all boils down to a pretty simple question, right? How does a computer learn to look at a picture and tell you if it's a cat or a car? I mean, for us, it's instant. But for a machine, that's a huge challenge. How on earth does it figure out the difference? Well, the systems that do this are often called black box models, and for good reason. We can feed them tons of data, and they spit out an answer. But what happens in between is kind of a mystery. And that mystery, it's a real problem. It makes these super powerful tools a bit untrustworthy, and sometimes they can make some really silly mistakes. So, how do we peek inside this box? Well, there's this really brilliant idea that says we should stop thinking about lines of code and start thinking about the shape of the data itself. Okay, stick with me here. Think about a single image. It's made of thousands of pixels, right? Each with its own color value. You can think of all those values as coordinates that place that image in a massive, high-dimensional space. Now, if you do that for thousands and thousands of cat pictures, they actually start to form a kind of distinct geometric shape. Let's make this way more simple. Imagine we have a giant sheet of paper. For every single cat picture out there, we put a little red dot on the paper. For every car picture, a blue dot. Got it? Now, take that paper and just crumple it up into a super tight, messy ball. That is what raw data looks like to an AI, just a tangled mess. Now, in the world of mathematics, this crumpled up, tangled shape actually has a name. It's called a manifold. It's just the underlying geometry of all our messy data. The red cat dots are on one part of the surface, the blue car dots are on another, but they're all crunched together and totally mixed up. And this brings us to this really beautiful, elegant idea for what's happening inside the AI's mind. It's called the manifold unfolding hypothesis. And some really smart researchers set out to prove that this is exactly what's going on. So here's the big idea. The entire job of a deep neural network is to just carefully and systematically uncrumple that ball of paper. That's it. Layer by layer, it's just trying to smooth out all those wrinkles and folds. So the whole journey looks like this. First, the AI gets that crumpled, tangled mess of data. Then it passes it through all of its layers, and each layer does a little bit of the unfolding work. And finally, at the very end, it outputs this perfectly flat sheet of paper where all the red dots are in one neat pile and all the blue dots are in another. Now, they're super easy to tell apart. Okay, that's a beautiful theory, right? But is it what's actually happening? Well, researchers found a way to literally watch this unfolding process in action. Let's see what they saw. So they started with some pretty complex image data sets. On the left, you see fashion MNSD. That's all different kinds of clothing. And on the right is CFIR10, which has pictures of everything from animals to airplanes. Each one of these is its own unique crumpled paper that the AI has to figure out. Now, how do you see the shape of data that exists in thousands of dimensions? Well, they use this amazing visualization tool called TSNE. The best way to think about it is like a tool that can take a 3D globe and perfectly flatten it onto a 2D map. TSNE does that for AI data, letting us actually see its shape. All right, here's the data right at the beginning, at the first layer of the network. Each color represents a different category. Airplanes, dogs, shirts, you name it. As you can see, it's a complete mess. The paper is definitely still crumpled. But now, watch this. After just a few more layers, look at that. The colors are starting to clump together. You can see these distinct groups forming. The AI is starting to pull the wrinkles apart. Let's go even deeper into the network. Wow, the process is really speeding up now. The clumps of color are getting tighter, cleaner, and they're pulling farther and farther away from each other. The separation is becoming so much clearer. And then at the very last layer of the network, look at that. It's honestly beautiful. Each color has formed its own tight, distinct little island. The paper is completely flat. Now the AI can just draw a simple line and say, okay, everything over here is a cat and everything over there is a car. It's an incredible visualization of the whole process. And it's not just some pretty pictures. The numbers tell the exact same story. This chart shows something called KL divergence, which is basically just a score for how messy the data is. And as the data moves through the layers from left to right, you can see that messiness score just drops and drops and drops. This visualization really drives home why we're talking about geometry. On the left is that final flattened result in 2D, but on the right, you can see it in 3D. That extra dimension makes it so obvious how cleanly separated these categories have become. They literally live in different parts of space. Okay, this is all super fascinating, and it's a really cool way to picture what an AI is doing. But so what? Why does this actually matter in the real world? What does understanding this geometry actually do for us? Well, understanding this geometry is frankly a game changer. It helps us build AI that's more transparent and helps us figure out why it makes mistakes. Think about an AI that reads medical scans. If we understand the exact geometric shape of a tumor versus healthy tissue, we could make those systems so much more reliable. And maybe most importantly, it could help us defend against so-called adversarial attacks. Those are images that look perfectly fine to us, but are secretly designed to trick an AI. If we know the precise shape of the cat category, it becomes much easier to spot an imposter. So this all leaves us with a really powerful, kind of mind-bending question. We've just watched this beautiful geometric dance as data gets unfolded inside an AI. If we can truly master this geometry, could we one day build an AI that's so robust that it's literally impossible to fool? That's the exciting new frontier that this research opens up. Thanks for watching.